Welcome to Speed Reads, Emotional Ignorance. Understand how emotions make us who we are. When neuroscientist Dean Burnett set out to write about the science of emotions, he approached the subject with cool academic detachment. However, as the COVID-19 pandemic unfolded in early 2020, he faced an unexpected collision between his professional and personal worlds. His own father died from the virus, and he was plunged into grief. It forced him, in the midst of his writing about emotions, to experience them at their most raw and overwhelming. This speed-read summary takes us from the neurons in our gut to the complexities of love and sorrow, from the evolutionary roots of parent-child bonds to the challenges of processing emotions in lockdown. It offers a deeper understanding of how our biological systems give rise to the rich and complex experience of being human. Let's begin. More than a feeling, emotions shape every aspect of human experience, from our deepest relationships to our most fleeting daily interactions. Yet despite their importance, scientists still struggle to define exactly what emotions are. What we do know is that emotions are deeply rooted in our physical bodies, perhaps more than most people realize. Take our digestive system. It contains a vast network of neurons, so sophisticated that scientists sometimes refer to it as a second brain. This neural network constantly communicates with our actual brain through a channel called the vagus nerve. Is it any wonder that anxiety often manifests as stomach butterflies, or that comfort food can be so comforting? These everyday experiences reflect a deeper truth. Our gut and brain are in constant dialogue. But the gut isn't the only place where emotions leave their mark. In the 1970s, psychologist Paul Ekman studied emotions through their manifestation as facial expressions. At the time, many scientists believed that emotional expressions were learned from culture, like languages, but Ekman found something remarkable. People from vastly different cultures, including a remote Papua New Guinea tribe with minimal outside contact, all displayed and recognized the same basic facial expressions for emotions like happiness, sadness, anger, fear, disgust, and surprise. This suggested that certain basic emotions might be hardwired into our brains, as fundamental as having 5 fingers on each hand. In recent years, however, psychologist Lisa Feldman Barrett has proposed a different theory of emotions. Barrett contends that our brains construct emotions in real time from a variety of sources: basic sensory data, memories, and bodily signals. It's a bit like how our brains construct our visual world. While our eyes only detect 3 colors, our brains create for us a visual experience which is much richer. This constructive process helps explain why we don't always have the same emotional reaction to the same thing. Context matters. A lover's face might bring joy during a relationship, but pain after a breakup. The brain, Barrett suggests, is creating and recreating different emotional experiences from similar raw materials based on context and need. Ekman and Barrett's research show two contrasting views of emotion. Ekman suggests we're born with a built-in set of basic emotions, a pre-installed emotional toolkit. Barrett argues our brains construct emotions from scratch each time, like a chef combining ingredients to create a unique meal suited to the particular situation. In either case, however, it's clear that emotions aren't just in our heads. They're whole body experiences that arise from an intricate dance between physical and mental states. Why the brain needs the heart. Imagine being able to switch off your emotions like a light switch, leaving only cool, rational thought behind. It's a compelling idea and common trope in science fiction. Consider Star Trek's Vulcans, an alien race that rejects emotions in favor of pure logic. The message is clear. Emotions are a weakness, a primitive holdover we'd be better off without. Modern neuroscience, however, tells a different story. Far from being separate from rational thought, emotions are deeply intertwined with how we think, decide, and act. Think of the hypothalamus as a central command center, sending signals throughout the brain that drive our actions. While we often imagine emotions and rational thought competing for control, they actually work together like two skilled pilots navigating complex terrain. The hypothalamus orchestrates everything from our most primitive impulses to our grandest ambitions. When our survival is at stake, whether we're parched with thirst or confronting danger, it triggers instantaneous responses. Yet, this same brain region also enables our uniquely human achievements. Whether composing a symphony or launching a startup, success requires both the fire of emotional drive and the steady hand of rational analysis. Even negative emotions play vital roles. When we're anxious or concerned, these feelings act like a spotlight, narrowing our focus and enhancing our attention to detail. So, with apologies to Dr. Spock, the dream of pure, emotionless logic is just that, a dream. As the author explains, trying to remove them from rational thought is like scraping the mortar from a brick house. It destroys the structure. Far from being a flaw, emotion is part of the foundation that makes thinking and acting possible. Our emotional memory banks. Emotional events can transform our memories in unexpected ways. When the author lost his father to COVID-19, he discovered that previously joyful memories had become painful. A brightly colored shirt, once a cheerful Christmas gift, now triggered sadness, and the smell of his father's favorite aftershave, formerly a source of comfort, became difficult to bear. These experiences show how emotions and memory intertwine. These moments highlight the way memory is shaped by experience. The hippocampus, our brain's memory center, creates memories by weaving together two things: sensory inputs and internal states, or in other words, what happened and how did we feel. Recording every detail of every moment would quickly overwhelm even the best memory. So instead, the brain prioritizes experiences that matter most, that is, those with emotional significance. To do this efficiently, the brain doesn't create entirely new memories for every experience. Instead, it reuses existing memories and their components. We might have a core memory of what our spouse looks like, and that memory gets linked to all our experiences of them. This approach conserves neural resources and allows our memories to connect and build on one another. This interconnectedness also means that memory formation isn't instantaneous. When we experience something significant, like making a social faux pas at work, we often don't feel the full emotional impact until later. Memory consolidation occurs slowly, allowing these delayed emotional reactions to be incorporated before the memory is fully set. Grief works in much the same way. When we lose someone we love, the sadness of their passing can infiltrate all our memories of them, like a stain seeping through fabric. Take the example of the colorful shirt gifted by the author's father. The shirt didn't suddenly become a different garment, but rather the memories connected to them were transformed by grief. Fortunately, our brains have evolved a mechanism to prevent negative emotions from dominating our memories forever, what psychologists call fading affect bias. While negative emotions are typically more potent in the moment, they fade from our memories faster than positive ones. We might remember that we were angry about something, but recalling it no longer makes us feel angry. Meanwhile, happy memories retain their ability to spark joy for much longer. Some research indicates that this bias is absent in people experiencing depression, helping explain why negative memories remain so persistent in depressive disorders. The fading affect bias, then, appears to be an evolved trait that helps maintain our mental well-being, allowing us to move forward after sadness while holding on to what brings us joy. How emotions connect us. Grief defies our expectations. While we might anticipate a steady stream of sadness, the reality is more complex. It comes in waves, periods of numbness, interrupted by bursts of intense feeling, moments of anger that come from nowhere, and even stretches of feeling normal, which may then bring their own burden of guilt. This emotional complexity becomes less mysterious when we understand how deeply social our brains are. At the most fundamental level, our brains evolved to learn from and connect with others. Even a simple action, like watching someone tie a knot, involves a complex process of understanding. The visual information traveled to brain regions that decoded the movement, predicted its purpose and its outcome, and prepared us to imitate it. This same neural network helps us recognize and share emotions, creating a bridge between minds, a bridge that predates language itself. This same neural system supports not only emotional recognition, but also emotional expression. As we saw earlier, humans are highly attuned to signals like sweat, tears, vocal tone, posture, and facial expressions. These cues register even when someone tries to hide how they feel. A child can detect their parent's masked sadness despite a smile, just as a spouse can sense their partner's unspoken anxiety. The power of these emotional connections becomes particularly evident when we're forced to suppress them, as often happens in professional contexts. Many workplaces expect us to maintain a pleasant demeanor regardless of how we feel, to laugh at the boss's jokes, remain calm in the face of hostile customers, or project confidence despite impossible deadlines. This constant emotional suppression takes a toll. When we bottle up our natural emotional responses, the effects spill into our personal lives, disrupting sleep patterns, straining relationships, and even contributing to depression. It's like trying to dam a river. The pressure builds up behind the barrier, finding new paths, and eventually weakening the very structures meant to contain it. This machinery of emotional sharing explains why isolation can feel so bad. Our brains evolved to process emotions in community, to share our joys and sorrows with others who can reflect them back to us. When we're cut off from this natural process, as many were during the COVID pandemic, we lose access to an essential part of our emotional processing. This biological need for connection runs deep, shaping how we respond to others and how we make sense of what we feel. It sets the stage for many of the caregiving instincts that define human relationships, which is what we'll explore next. Why we care for each other. During their weekly family meal together, the author's father turned to him and launched into an impassioned speech. He had been spending months providing daily support to a relative battling Parkinson's, and the experience had opened his eyes. The hours of dedication, the constant vigilance, the emotional toll, all of it, he insisted, was consistently overlooked by society at large. Yet people still do it. After his father's death just 3 months later, the question stuck with him. Why do humans make such profound sacrifices for each other? The answer points to something fundamental about how our brains process emotional bonds. Consider what happens when a parent holds their newborn for the first time. As one father described it, the moment when doctors handed him his newborn child shattered years of carefully maintained emotional control. The rush of competing feelings, joy, terror, love, anxiety, overwhelms our usual capacity for emotional regulation. Yet this is biology in action. The hormone oxytocin floods both parent and baby's systems, literally rewiring their brains for attachment. This biological foundation for parent-child bonds served as an evolutionary template for all human emotional connections. Rather than develop entirely new systems for forming attachments to friends, romantic partners, and community members, evolution modified the existing parent-child bonding mechanisms. This efficiency helped make humans an ultra-social species capable of forming deep emotional connections far beyond immediate family. The power of these attachment systems shows up in surprising ways. Consider the common urge to squeeze or pinch something unbearably cute, a phenomenon scientists call cute aggression. This seemingly bizarre response occurs because seeing something adorable triggers such an intense positive emotional response that it activates both our nurturing and protective instincts simultaneously. Our brains become overwhelmed trying to process these competing signals. This brings us back to caregiving. Whether we're caring for children, elderly relatives, or others in need, we tap into ancient emotional circuits that evolved to ensure human survival through connection. Understanding this doesn't make the work any less demanding, but it helps explain why humans continue to make profound sacrifices for others, often with little external reward. These emotional bonds, first forged between parent and child, have become central to our very being. Emotions in the digital age. After his father's death due to COVID-19, the author found himself confronting an unexpected dilemma: how to use Facebook to broadcast his father's funeral. The platform, typically reserved for cat photos and lighthearted social updates, had to serve as the medium for sharing one of life's most difficult moments. This juxtaposition felt deeply wrong, yet was unavoidable during the lockdown. His father's hundreds of friends and colleagues needed some way to say goodbye. This experience highlights the limitations of digital communication in moments that call for real emotional presence. Video calls and text-based platforms miss the subtle, multi-sensory cues of in-person interaction, slight shifts in posture, micro-expressions, body language, even pheromones, and the calming effect of physical proximity. Yet, these platforms have become central to how people express and process emotions today. This technological mediation of emotion has far-reaching consequences, particularly in how information spreads and beliefs take hold. During the pandemic, the author encountered people online who insisted COVID-19 wasn't real or dangerous, effectively denying in his eyes the reality of his father's death. These kinds of encounters reveal how the brain protects existing beliefs through multiple psychological mechanisms, from confirmation bias to active rejection of contradicting evidence. When information triggers emotional resonance within online communities, it often spreads regardless of factual accuracy. The author's scientific background initially suggested that the solution was to separate emotion from information processing, to approach everything through pure logic and reason. But studying emotions while processing his own grief led to a profound realization. Emotions aren't flaws in human programming to be eliminated, but fundamental components of how humans think, learn, and make decisions. Even the desire for pure rationality is itself emotionally driven. Emotions can lead us astray but remain essential to human experience. Final summary. The main takeaway of this summary, To Emotional Ignorance by Dean Burnett, is that emotions are fundamental components of human thought and behavior, shaping how we interpret the world and make decisions. Emotions shape memory, guide decision-making, support social bonds, and drive caregiving. They are embedded in our biology and constantly active in how we process information, connect with others, and respond to life's demands. Recognizing their role brings us closer to understanding how the mind works and how we live within it. Okay, that's it for this summary. We hope you enjoyed it. If you can, please take the time to leave us a rating. We always appreciate your feedback. See you in the next summary. Thanks for listening to Speed Read.